Good evening, everyone. Am I audible to all of you? Please quickly tell me.
Good evening, sir. Yes, sir, you're audible.
Yes,
Okay,
sir,
thank you.
audible.
In today's class, when we start the topic of basic numeracy, I have already given the introduction in case of the initial introductory class of basic numeracy as well as during the webinar. I'm straight away going to start with the topic of percentages. Normally, when mathematics is taught, the first set of topics are from arithmetic. In arithmetic, the first topic is number system. But the problem with number system is that number system is a very dull, dry topic, and it requires a lot of knowledge about other topics. That is the reason why I prefer starting the whole of basic numeracy with the topic of percentages. The target is, there's several targets. First of all, in case of the topic of percentages, I will be giving you a lot of questions in which you will have to do a lot of calculations. Now, whether you come from a maths background or you don't come from a maths background and have a fear of maths, in both cases, calculations is something that you will be slightly out of practice with. I am going to initially teach you how to do questions by the hard calculation method. But at a later stage, we are going to learn the right strategy for doing that question. Every question in case of basic numeracy can be solved by several methods. One of those methods is called a strategy. Strategy is that particular method which takes least amount of time. It has least number of calculation steps. It requires easy formulas and it does not require a lot of calculation as such. Because every calculation you make, there's a chance of you making a silly mistake in terms of calculation. And in the actual examination, you will not have a lot of space to do rough work. So, strategy should be a method in which there are less amount of calculations and it takes less amount of time, but at the same time, you should be able to maintain 100% accuracy. So, we are going to look at strategies once in a while, initially, and later on, we are going to study only from strategies as such. But I definitely want you to do a lot of calculations along with me when I tell you to do calculations. So, if you are somebody who's very good at maths and you can do a question faster, uh, I welcome you. If I'm teaching you something which you already know, then you should relax, feel confident that this is some stuff which I already have an idea about. But in case there is something new which I'm telling, if I tell you something which clashes or is different from whatever you already know, then I want you to clarify it with me. So, let's start. If I look at the topic of CSAT, the whole of the paper of CSAT, then CSAT will directly test you on percentages directly in the form of numerical problems and word problems. Apart from that, percentage is a topic which is part of foundation of mathematics. So its fundamental skills are required in many areas of mathematics, many areas of your basic numeracy. For example, if you look at it, the whole of your basic numeracy section has topics such as averages, mensuration, time and work, reverse board streams, stocks and shares, pipes and cisterns, profit loss discount, time speed distance, allegations and mixtures, fractions, ratio, proportion, simple and compound interest, profit loss and discount, and many kind of word problems which appear as part of your basic numeracy section or the quantitative reasoning section. Apart from this, the data interpretation section, which includes table analysis, data sufficiency, two-part analysis, graphic interpretation, and multiple source reasoning, all of these topics require you to be excellent at percentages. So, percentage is the most important topic out of the whole of your syllabus of basic numeracy. So, let's get a slight idea about what a percentage actually is. I am going to start every topic, whether it is from basic numeracy or any other area, right from the basics as such. I am taking for granted you don't know anything. So if you already know the stuff which I'm talking about, you need to feel happy and confident and relax. So the word percentage, it actually comes from the word cent. Cent means 100. So percent would mean per 100 or for every 100. So if we talk about 30% of something, it basically means 30 parts out of 100 parts of that thing. So if I want 30% of the revenue of a particular company, it means if I break up that whole company's revenue into 100 parts, then out of those 100 parts, I need 30 of the parts. So 30% is also written as 30 upon 100. So percentage is a fraction where the denominator will always be 100. And if I take an example, suppose you have a square wooden board whose size is 100 centimeter multiplied by 100 centimeter. and you go in for cutting this board into 100 equal pieces, and each piece is of the size 1 centimeter multiplied by 1 centimeter in this particular manner. And then you write numbers upon all of them, 1 to 100, because there are 100 pieces. Then 30% would mean 30 of these pieces out of the 100 pieces of that whole board as such. You can also go in for separating them out. So when I separate out 30 pieces out of 100 pieces of this whole board, then these brown pieces are the ones which represent 30% of the whole board as such. So this is 30%. You can call it 30 upon 100 of that particular board. Or the remaining board is 70%, which is 70 upon 100. This is what percentage actually means. Now, in case of percentages, you can get very easy questions or super difficult questions. So what we are going to do is I'm going to give you a set of 5 questions in all, easy 5 questions. I want, and these questions don't require any formulas. They require you to blindly understand what the question is asking for, try to calculate out the answer, and you all studied mathematics till your class 10 standard, even if it is slightly rusty, even if you're slightly out of touch with it. I still want you to try your hand at these 5 questions which I'm giving you. So just give me a moment. I'm going to share a document with you all. I have shared a document on chat. I want you to download that document, and I'll open up the document on the screen also. I want you to attempt only the first 5 questions of this document. Don't worry about time. Don't hurry. Do it carefully. You can do all of these 5 questions without a formula. You don't need to send me the answers. Don't worry about sending me the answers. We'll discuss all of these questions later on. But I want you to fight with all of these questions. See if you can try doing them. And cameras are off. You need to turn on your cameras, guys. Priya, Lamlinti, Rishika, Diksha. This is for your own benefit.
Sir,
Yeah, tell me. Any question?
yes, sir. I got late.
Okay, not a problem. I'm sharing this exercise once again. I want you to download it.
Okay. So what method has to be used?
Any method. I've not taught anything so far, don't worry.
Okay.
So I'm going to teach everything, but I want you to give it a try. At least attempt question number two. That's all. And then we discuss in another 2 minutes. Okay, let's start. The most basic question which can be asked in case of percentages can be a question like this one, which says, what is 20% of 1900? The way to solve this particular question is that when it says what is 20% of 1900, then it is basically asking for replacing the word of with the multiplication sign. You know that 20% means 20 upon 100. So you need to multiply 20 upon 100 by 1900. And when you simplify it, then you can simply cancel off the two zeros in the denominator and in the numerator, and you will end up getting 20 multiplied by 19, which comes out to be 380. As a result, you mark up 380 as the answer. This is the easiest possible question which can come on percentages. So whenever they ask you what is a particular percentage of a particular number, all you need to do is replace the of with a multiplication sign and write down that particular number upon 100 multiplied by the other number whose part we are looking at. Simplify it and you'll end up getting the answer. This is the first basic simplest of questions. Things get slightly more difficult when the question goes in for asking you something like, what percentage of 940 is 376? So 376 is a certain percentage of 940. That certain percentage, we'll assume it as x when we solve it. So let x percent be 940 of 940 be equal to 376. So I replace this off by a multiplication sign and I will end up making this equation. x upon 100 of 940 is equal to 376. This is what the question is saying. This x has to be found out. We know that x% means x upon 100. That's the reason why I wrote x upon 100 here. Now, I'm going to make a little bit of shifting to solve the question. Whatever is in the denominator here at the bottom, I'm going to put it here at the top in the numerator on the other side of the equal to sign. And whatever is present on top, I will put it down in the bottom. So I will end up getting this kind of an equation where x is equal to this 376. This 100 will go up. So I'm multiplying it by 100. And this 940 will come down in the fraction, 940 here. As a result, when I simplify it further and I calculate out the answer, I will end up getting x equal to 40%. For people who think they are weak in mathematics, I want you to write down this question and the complete solution once, along with me. This is the second level of difficulty. This is slightly more difficult than the previous question. I'm doing the absolute basics at the moment. Then, when they ask you what percentage of 30 is 7.35, then the thing which has to be found out, let's call it x. And I will say let x of x% of 30 be equal to 7.35. I know that x% basically means x upon 100. Of basically means a multiplication sign. As a result, I'm getting this kind of an equation made. So question is saying x upon 100 multiplied by 30 is equal to 7.35. We have to find out the value of x. So when we try to find out the value of x, all I need to do is when I change the side for this 30 and I put it this side, then because 30 is on the top, it will come at the bottom. Because 100 is at the bottom, so it will come on the top. So the equation will become this one. Here the 100 at the bottom has come at the top, and this 30 which is at the top will come at the bottom in the denominator. I simplify it further, and I will end up getting 24.5 in my solution. This is a repetition of the same kind of question like the second one. Nothing new here. Only these values have changed. I will repeat. If you think you are weak in maths, then I want you to write down everything which appears on the screen along with me. Let's move ahead. Now we look at the same question once again, but in a slightly different manner. But this way of solving the same question, which is an easier way, is a way with which you will be comfortable after you've done a lot of calculations. If you look at this particular question's language, then a smarter way of doing this particular question is by doing it through the options instead of actually calculating here. For example, we all know that 25% of 30 is equal to 7.5. So if 25% of 30 is equal to 7.5, because 7.5 multiplied by 4 is equal to 30, then automatically 7.35 is less than 7.5. This is the number that we are talking about. then the correct answer has to be less than 25. The only answer which is less than 25 is a choice. So by this faster way, we can possibly end up getting the answer also without doing a much of calculation. But this sense of thinking that 25% of 30 is equal to 7.5 is something which you will develop after you've done a lot of calculations. This is the reason why when I teach percentages as a first topic, my focus is upon percentages as well as giving you a lot of calculation practice also. Then your brain can start working in this particular manner. Now we are learning the first concept. So I want you to concentrate. This is a concept which is not taught in schools. But yes, in case of aptitude tests such as CSAT, IMCAT, GRE, GMAT, SAT, in all of these examinations, this particular concept is tested. This is also a concept on the basis of which the most difficult question of the first year of CSAT really came. So let's understand. Suppose I have this particular question. Read this question properly. So let's look at the question. The question says Sid saves 40% of his earnings every month, while Nick saves 30% of his earnings every month. And the question says, does Sid save more money than Nick every month? The problem with this particular question is the question is talking about percentages of earnings of Sid every month and percentage of savings of earnings every month for Nick. And although the question talks about percentages, the real thing which we have to find out is does Sid save more money? But neither the first information nor the second one tells me about any money. It only tells me about part of that money, 40% of the earnings, 30% of the earnings. But the earnings of Sid and the earnings of Nick are not written. Suppose the question would not have asked this thing, and the question would have asked, does Sid save a greater percentage of his earnings every month as compared to Nick? Then the answer was a yes. But as far as this question is concerned, does Sid save more money than Nick? This is a question whose answer we do not have much of an idea about because the data is missing. Because this question is not talking about the absolute value of money which Sid earns or the money which Nick earns. This data is missing, so we cannot tell the answer. Because we don't know the amount of money earned every month by Sid and Nick, so we do not know the answer to this question. Data is insufficient. The question has less of data. We need more information in the question, only then we can answer this question. So let's understand it. Suppose monthly earnings of Sid are 10,000. Then because Sid is saving 40% of his earnings, so 40% of 10,000 will be $4,000. On the other hand, suppose Nick's earnings, monthly earnings are $30,000, then his savings would be 30% of 30% of 30,000. As a result, his savings would be $9,000. as a result of which Nick is saving 5,000 rupees more than Sid. So I need these two values, this value 10,000 and 30,000 written in this question. Only then we can possibly give answer of this question. The main point which I'm trying to make out here is that percentage is not a number. Percentage does not have an absolute value. A percentage is part of a number, or it is a fraction of a number. Based upon this concept, which is not taught in schools, this particular question appeared in the exam when the CSAT was conducted for the first time. I want you to spend 2-3 minutes upon this if you've not seen this question before. And share the answer in chat.
Sorry, I'm not audible.
You're asking something?
Yes, sir, I want to.
Tell me, speak.
So, for the previous question, what were the options in the exam? Will there be any options such as data insufficient?
Oh, no, yeah, there would be an option saying data insufficient in that case. So this is the question. The question on the screen is the question which appeared in the exam.
Okay, sir.
So I want you to work upon it. Okay, let's start. When this question came on the exam, depending upon a student's background, students responded to this particular question in different ways. Also understand one thing very clearly. This question is based upon a concept which is not taught in schools. But that concept automatically develops in the head of students who do a lot of mathematics, who do a lot of calculation. So students who do a lot of calculation, they don't have to be told that percentage is actually not an absolute number. It is part of something. Fraction is not a number. Fraction is actually part of something. So a lot of students who were comparatively weak in maths, when they saw this long question, and it also had these pie diagrams which are given here, they decided that this is too difficult a question to even work upon. But the problem is that anyone who rejected this question and decided not to do it actually made a mistake. Because this question actually tests you upon things which are taught in fourth standard, class fourth. Subtraction, addition are two things which are taught in class fourth. Fractions are also taught in class fourth for the first time. So let's see. If I don't know how to do this question, but I still try doing it, then what do I have to do? I'll have to possibly read this part information, which will not help me much. And then the question says, which of the following statements must be true? When I read this particular thing, then I will have to read the first statement. The first statement says, the money spent on food over rent in the month of January is the same as money spent on food over rent in the month of February. At this particular stage, I can make a mistake. And the mistake which I can make is I may end up thinking that they are talking about food upon rent. fraction, where food is the numerator and rent is the denominator. This can be one meaning of this initial part of the sentence, and that will be a mistake. When the question says money spent on food over rent, it basically means a difference in the amount of money spent upon food and the money spent upon rent. So we don't have to divide it. We'll have to subtract it. So when it says money spent on food over rent in the month of January, that is already written here very clearly. 30% upon food, 20% upon rent. So difference of 30% and 20% is what it is talking about. As a result, this part is talking about 30%, which is money spent upon food, and 20%, which is spent upon rent. So 30% minus 20% gives you a 10%. So I end up getting a 10% as an answer here. And then it says this 10% is the same as the money spent on food over rent in the month of February. This is also written there. So if I look at money spent on food over rent in the month of February, then that is mentioned here. 25% upon rent, 35% upon food. Now 35% minus 25%, I will get this equation. That 35% minus 25% is equal to 10%. But remember, is this 10% equal to this 10%? It can be equal. It can be equal if the expenditure of the month of January is equal to the expenditure of the month of February. And that is not written here. How much money did he spend in January and how much money did he actually spend in the month of February is not written here. The total amount of money is not written here. And if you look at this particular graph, this particular figure which is given here, then always remember in basic numeracy questions, even if it is a geometry question, if a figure has been given, that figure is not there to help you. The figure is always there to confuse you. So even when figures appear in case of geometry questions, which cannot be done without the figure, that figure is never drawn to scale. As a result, if you just blindly believe in the figure, then you will end up making a mistake. The reason why they have given these two pie graphs is that both of these pie graphs have a circle of equal sizes. This gives you the false impression that possibly the expenditure of January is equal to the expenditure of February. But it is not written anywhere here. Because it is not written anywhere here, yeah, Prerna, ask me.
So my doubt is that, sir, we also learn unitary method
Yes.
in junior classes.
Yeah.
So, sir, can we use unitary method here?
We can use unitary method here if I know what is the value for January and February.
Okay, so it is essential to know the salary of whatever.
Yes,
Yeah.
yes. Unless and until I know the
Okay.
actual number, I cannot find a percentage of that number.
How is this question related to maths? Is it not reasoning?
It is absolutely all questions are actually reasoning questions. Even in case of the English part, you will realize that all questions are actually English reasoning questions, verbal reasoning questions. So this is checking you for your smartness. It is not checking you for the maths. If
Yes,
you
I
do not
was
know
about to
maths,
say that.
then you don't have to worry about it because maths is not coming on this exam. So the 10% of January and 10% of February, we do not know whether they are the same or not. As a result of which, we cannot be 100% sure about statement number one. It is not must be true. It is may be true. If the expenditure of January and February is the same, then it may be true. And if it is different, then it is definitely wrong. So because 10% of January may or may not be equal to 10% of February, and this data is not given, what is January's expenditure, what is February's expenditure? So getting just the value of percentage is not enough. As a result of which, because total expenditure of January and February is not given, statement 1 is incorrect. Now there is one more confusion here. If you are good enough to find out that yes, statement number 1 is something which is not a must be true statement, and then you read statement number 2 happily, and you'll realize that its language is the same as the language of the first statement. It says the money spent on rent over clothes is the same as money spent on food over rent in the month of January. Because the language is very similar, if you found out that data is insufficient for the first statement, your heart will say So because second statement is similar to the first statement, so data will be insufficient here also. If the first one is wrong, then the second one can also be wrong. But there is a catch here. And the catch is that when I look at money spent on rent over clothes, then that is mentioned here, which is 20% minus 10%, which is equal to 10% of January. And when I look at money spent upon food over rent in the month of January, then food is also given here, which is 30%, and rent is also given here, which is 20%. So 30% minus 20% is also equal to 10%. But both of these 10% are 10% of January. As a result of which, even if I do not know what is the total expenditure of January, a 10% of January will still be equal to 10% of January. As a result, the second statement is perfectly right. And because second one is right, as a result of which I'm going to pick up B Bombay's answer. You can see that the language of the question is such that at several stages you can make a mistake. Even not attempting this question is a mistake because it's a super easy question. Everyone can subtract a 20 from a 30. Everyone can subtract a 25 from a 35. This is the only calculation which is involved here. There's this calculation also of 10 being subtracted from a 20. This is something which everyone can do. But what is missing out here is that students may end up making a mistake upon this question if they do it quickly and they do not do it carefully. Also, you need to be somebody who has a sense of percentages. And sense of percentages, which is not taught in schools, is developed automatically by doing a lot of questions. This is the reason why I need to give you a lot of practice of calculations. Are we clear upon this question? Can you move on ahead?
Yes.
Yes, sir.
Okay. Now do this question yourself. Take 2-3 minutes. Ready? In this question, it says in 2023-24, revenue of Amul grew by 18%, while taxes increased by 11%. What was the increase in profit percentage? In this question, you also have to understand and have some background knowledge. Background knowledge which is required is that revenue means the total amount of money a company earns. And profit means all revenue minus all expenses minus all taxes. I do not have any information about the expenditure of the company Amul. This is a problem here. So even if revenue of Amul grew by 18% while taxes increased by 11%, when students attempt this question, and this question on the face of it looks super easy, then because the question looks easy, they think that it is easy to solve also. And a lot of students will be tempted to simply subtract 11% from 18%, and they will end up getting 7% as the answer, and they will mark 7% as the answer. Some of these students who do not know how to do this question, when they look at this C choice, which is actually a wrong choice, and it is a very complicated choice, this will stop a lot of students from attempting this question, even if they know how to do it. Because they will think probably this is a very complicated question which requires some equation, because of which you will end up getting this complicated answer of 1 minus 118 upon 111%. And you cannot subtract whatever this value is in terms of percent from 1. This calculation cannot be done actually. So they will simply decide to leave it. But the problem is that this question has in data which is missing. The data which is missing is the total taxes to be paid and total expenditure of Amul. Only then we can find out the profits or the profit percentage. And to find out the profit percentage, we'll possibly have to do an even next step of calculation. So this question's answer is option D, data insufficient. The data which is missing is total expenditure, total revenue, total taxes, not percentage values. This cannot be calculated based upon percentage values. Yeah, Prerna, ask me.
My doubt is that, so even I, in the first instance, thought that the answer is 7. But then I thought that how will how will anyone calculate if there is no value given?
That's the point. That's the point. But then the good thing
So,
is that to make it even more confusing, they've only given percentage as percentage values. So we get an impression that possibly I can subtract 11 from 18. Both of them are in percentages, and I end up getting an answer in percentages. So the question
yeah,
is
but
not
then,
difficult. Question is confusing. That's all. And
so, but then I,
confusions, yeah, ask me.
but then I thought that for the previous question, you explained that there is nothing from where you can calculate. Here also,
Yeah,
there is nothing from, and then percentage minus percentage, thoda, it is odd. So,
So what
sir,
answer
is
did you
this
have?
the, I think it is D,
Yeah.
but is this the right way of thinking
Yes,
for
this is the right way of
maths
thinking.
question?
Perfectly right way of thinking. There's a lot of data
Okay.
which is missing here, but there is one important data which is actually missing, apart from the actual values, and that is expenditure of Amul.
So,
Yeah, ask me.
so if we are calculating not this question, but for the
Mhm.
statement, while taxes increased by 11%,
Yes,
so that 11% should be the increment of from the previous year percentage of
yes,
tax or
yes,
the
yes,
amount
yes.
of tax.
And I don't know that value of previous year.
Yes, sir.
So there's a lot of
So,
data which is actually missing in this question.
okay, sir.
So this is one concept
So,
which has to be clear. I want you to write along with me. I'm going to teach very easy things, but I want you to all to write it down. Then, yeah, Tushal, ask me.
so in this question, total revenue is missing, total amount of taxes for the previous year is missing,
Good.
and the total expenditure.
Total expenditure is missing. Yes. And what is
So,
the actual revenue? That is also missing.
could you explain the rationale why we need to know total expenditure?
Because profit is equal to revenue minus taxes minus expenditure.
Okay, so we are including all expenses. I mean,
Yes.
in expenditure only.
Yeah.
Okay, got it.
Okay. Next concept. Very easy, but you should be 100% clear about it. You should not be thinking about it in the examination hall. You should be automatically doing it from your muscle memory. You may require to convert fractions into percentages. For example, if you are given 1 by 4, What does 1 by 4 mean in terms of percentages? 1 by 4 actually means 25%. So how do we get this 25%? How do we see a 1.4 written somewhere and understand it is actually 25%? This conversion is what we are learning. So whenever you have to convert a fraction into a percentage, always remember you have to multiply the fraction by the 100. Simplify it. And then you have to add a sign, percentage sign. So if I get a 7 upon 20, then the easy way to convert it into a percentage value is 7 upon 20 multiplied by 100, simplify it, and then you add whatever is the value, you add a percentage sign to it. So if you have to convert 7 by 20 into a percentage, you will have to multiply 7 upon 20 by 100, simplify, and add a percentage sign. As a result, you end up getting this kind of a situation. 7 upon 20 multiplied by 100, you simplify it further. You know that 25 is 100. So 7 multiplied by 5 is equal to how much? 35. Once you've got a 35 after simplification, you need to put a percentage sign with it and you end up getting your answer. Answer is 35%. Is this clear?
Sir, is this the same concept as the document you shared in the third question about tin and copper? Similar type of
Yeah, yeah.
concept?
The tin and copper question is going to require this.
Okay.
But this is not the only concept which it would require. It would require more things also. There, in case of tin and copper question, the biggest problem is what will be the denominator and what will be the numerator. But we'll learn that, don't worry. Now, next concept. How to convert a percentage into a fraction. For example, if the question uses the words 20%, how to understand that 20% actually means 1 upon 5 if I need to worry about the fraction value. So the method to do that is you have to divide the percentage value by 100 and simplify and you end up getting a fraction. For example, if you are given 35% and you have to convert it into a fraction, then you need to divide the percentage value 35, which is given, by 100 and you have to simplify it. So 35% actually means 35 upon 100. When I go in for further simplifying it, I know that 5 sevens are 35 and 5 20s are 100. As a result of which, I can do a small amount of simplification here and I will end up getting 7 by 20. So 35% is equal to 7 by 20. I'm moving ahead. I'm expecting that you have already written it along with me.
Done, sir.
Okay. Next concept. Converting decimals into percentages. Suppose you get a decimal value such as 0.793 and you have to convert it into a percentage value, which is 79.3. So how do we get this 79.3? There are two methods to do that. First method is that you move the decimal position 2 digits towards right and add a percentage sign. So if I have this number, then I need to change the position of this decimal position towards the right. I'll bring it twice. First position, second position. So I will end up getting 79.3. Then I will add a percentage sign. This is the way to do it. So let's do it in detail now. A second method is you can multiply the number in decimal by 100 and then you can
Sir,
add a percentage sign. Yeah, ask me.
sir, we have to write the procedures also.
Yeah, yes. Initially, I'll tell you when you have to write the procedure. This has to be written. There are two methods to do this.
Okay, sir.
So if I have to convert 0.67, which is a decimal value, into a percentage, remember the method is move the decimal position 2 digits towards right. So this is 1 digit towards right, this is second digit towards right. I end up getting 67.0. And then I have to add a percentage sign to it. So 0.67 will be equal to 67%. The second method is you multiply the decimal value by 100, you end up getting 67, and then you add the percentage sign. So you end up getting 67%. So 0.67 is equal to 67%. I can do it by two methods. One method is move the decimal position twice towards the right. You end up getting 67, add a percentage sign to it. You end up getting 67%. Second method is multiply 0.67 by 100 and then add a percentage sign. Any of these two methods is okay. You should do these things without thinking. And for you to do it without thinking, you should have done a lot of calculations. I'm moving ahead.
Done, sir.
How to convert percentages to decimals? For example, if I get 64% written somewhere, how do I convert it into a decimal value, which is 0.64 in this particular case? So the method is you have to move the decimal position 2 digits towards left and then remove the percentage sign. So if you have, or second method is divide the number in percentage by 100 and then remove the percentage sign. Any one out of these two methods is okay. So if you have to convert 74% into a decimal, then you have to move the decimal position 2 digits towards left. 74% means decimal is present after 4. So what I will do is I will move it towards the left. This is 1 digit towards left, this is second digit towards left. And now the decimal will be before 7. And I will remove this percentage sign. So I will end up getting 0.74%. And once I've removed a percentage sign, it would become 0.74. So the second method is divide the given number by 100. You end up getting 0.74. Now you remove the percentage sign and you end up getting the actual decimal value. These are all very easy tidbits of concepts which we are learning at the moment. Each question will involve several such concepts. So when you're doing those questions in the exam, you should not be thinking about these concepts. You should have done so much of practice that you don't need to worry about the concepts which you are learning at the moment. Okay. Now we are learning a second set of concepts as such. I want you to convert the following percentages into fractions. 12.5%, 62.5, 37.5, and this particular value. Convert them into fractions. We've already learned that. 3 minutes. Not a single mistake. You need to read the question again. Prerna, you need to read the question again. You have to convert these percentages into fractions, not into decimals. Decimal is different from fraction. Fraction is x
Let's
upon y.
start. I'll do it again.
Yeah. Okay, let's attempt. When we talk about 12.5%, that is basically equal to 12.5 multiplied by 1 upon 100 or 12.5 divided by 100, and we remove the percentage sign. As a result, we end up getting 125 upon 1000, and 125 aids are 1000. I don't remember the table of 125, but I remember that 125 plus 125 is equal to 250, and 250 comes 4 times in 1000. As a result, it should be 1 by 8. Similarly, if I look at 62.5, then 62.5% is equal to 62.5 multiplied by 1 upon 100 or 62.5 divided by 100, which is equal to 625 upon 1000, and this is equal to 5 by 8. 37.5 is equal to 37.5 divided by 100. On simplification, I end up getting a 3 by 8. In a similar manner, for 16.665, when I'm divided by 100, I will end up getting such a large value divided by about a lakh. This is actually equivalent to 1 by 6. Now, whatever I have done here is something which I'm not expecting you to do. This is a mistake if you do this. The reason behind that is there is something else which we need to do. After learning that thing, you don't need to do these calculations at all. So now I want you to be ready with your pen and paper and understand and write down whatever is appearing on the screen. There is something called as fractional equivalents of percentages. These have to be mucked up. These have to be learned by rote. These should be on your fingertips without thinking, without calculating. So if I look at 100%, 100% means 100 upon 100, which is equal to 1 upon 1, which is equal to 1. So whenever you see 100% written anywhere, understand it means 1 or it means 1 upon 1. Exactly half of this is 50%. So 50% basically means 50 upon 100, which is equal to 1 upon 2. As a result, whenever you see 50% written anywhere, it basically means the fraction 1 upon 2. Half of 50% is 25%. So when I make half of half, it will become 1 upon 4. That is the reason why 25% is equal to 1 upon 4. Whenever you see 25% written anywhere, you should think about 1 upon 4. Now, if I look at what number comes between 50 and 100, that is 75. 75% is basically equal to 3 upon 4. Why is it equal to 3 upon 4? Because 75% means 75 upon 100. 75 and 100, both of them are divisible by 25. So 25 3s are 75, 25 4s are 100. As a result, 75% is equal to 3 by 4. This is to be learned. ये रटना पड़ेगा. In a similar manner, half of 25% is 12.5%. So half of 1 by 4 will be equal to 1 by 8. So in your mind, there should be no difference between 12.5% and 1 by 8. They're both the same. Also, between 50% and 25% is 37.5 exactly. And 37.5 is nothing but 3 upon 8. So if there are 3 12.5 on top and there are 8 12.5s at the bottom, then that is equal to 100 here and 37.5 here. So 37.5 is equal to 3 by 8 is something which you have to learn, mug up. Don't even do the calculation. Exactly between 75% and 50% is 62.5%. So when you subtract 12.5 from 75%, or if you add 12.5% to 50%, you end up getting 62.5. 62.5% is equal to 5 by 8. There is no difference between these two values. They are both equal. Exactly in the middle of 100% and 75% is 87.5. So if you add 12.5% to 75%, you will end up getting 87.5. If you subtract 12.5% from 100%, you will end up getting 87.5%. This 87.5% is equal to 7 by 8, or it is equal to 7 multiplied by 12.5, 8 multiplied by 12.5, which is equal to 100 below and 87.5 on top, which is equal to 7 by 8. So these values should be mugged up. You have to learn them. Ratna padega. You have to ratify them. Then there are some easy values which you should revise once again. For example, 10% is equal to 1 upon 10, or it is equal to 10 upon 100, so it is equal to 1 by 10. 20% means 1 by 5. 30% means 3 by 10. 40% means 2 by 5. And then there are those 1 upon third parts. For example, 33.33% is equal to 1 by 3. Double of this is 66.66. So double of that would be, double of 1.3, 1 upon 3 would be 2 by 3. And half of that, half of 33.33 is equal to 16.67%, which is equal to 1 by 6. So remember these values, the whole set of these values. If you add 16.67, 1 upon 6 to 66.66, you end up getting 83.325, which is equal to 5 by 6. Look at all the values which are written here on the screen. I want you to write them down. I want you to mug them up. Learn all of them. Repeat them 20 times, you'll remember them. I do not want you doing these calculations when you're doing questions. I want you to remember them. Take a screenshot of the present slide and save it. Okay, next thing. How do we use these values as such? If suppose you have to calculate 62.5 of 888 or 888, then the classical school way of doing this is that you put 625 on top, 1000 at the bottom, you multiply it by 888. But the smart way, which you can use if you have mugged up all of these values, is that whenever you see 62.5%, your brain should be thinking about a shortcut that 62.5 is equal to 5 by 8. And you simply multiply 5 by 8 by 888. And now choose between these two methods. Do you want to use this calculation or do you want to do this calculation? The second one is definitely better. Yeah, Prerna, you're right. This is how mugging up these values is going to help you. All of these values. Also remember, in your exam, you will not have questions having a 73.4% value. You will have more questions having, or rather almost all questions having a value of exact integral value as such, which is 75%. So if you remember this, you can do that question faster.
Sir, I did
Yeah.
not understand what you just said.
If you remember that 62.5 is equal to 5 by 8, and there's a question in which you have to find out what is 2.5% of 888, then the calculation becomes easier because of it.
So you
This is
were
the
telling
point
us
which I'm trying
something,
to make.
and you told us something about the questions which come.
Yeah. So in case of the questions, in case of questions, when you, the values which are given in questions, they will be integral values. You will not have a question saying what is 73.224% of something. Instead, you will have 75% of something. And when you see the 75% written there and you remember that it is equal to 3 by 4, then doing the calculation faster is easy.
Okay, sir, that
So these
it's
values keep on getting repeated. This 87.5 is important. This 62.5 is important. 37.5 is important. 12.5 is important. 16.67% is important because these are the values which keep on getting repeated. The data given in questions is such, it will have integral values. It will not have a value like 75.719. It will have 75%. Simple. That is the reason why these values become very important for us. Suppose question requires that you need to calculate 37.5% of 40, then the schoolish method or the classical way is you'll have to do this calculation. 37.5% of 40 is equal to 375 upon 1000 multiplied by 40. This requires calculation. But the shorter cut is if you remember that 37.5 basically means 3 by 8, then doing this calculation is always easier. This is easy, this is difficult. So you will have to mug up what 37.5% is equal to. It is 3 by 8, simply. Now, just mugging up is not enough. You'll have to practice it forcibly when you're doing calculations, when you're doing questions. Now we're learning a newer set of concepts here. These are the kind of the concepts which actually come in the exam. They are complete concepts as such, on which a complete question would be based. There is a concept of increasing or decreasing by a percentage value. For example, and the equation for that is this equation. I want you to write it down first, then we'll understand what it is all about. Please write down the equation for increase or decrease by a percentage value. Percentage increase or percentage decrease. Just write down the equation. The final value is equal to 100 plus minus x upon 100 multiplied by initial value. Okay. Suppose the revenue of a company, how much money the company earns, was $32 million. If this revenue increased by 25%, and the question asks you what is the present value of revenue of that particular company, then we are going to use this particular formula here. Solution is that present value is equal to 100 plus x. Because the revenue has increased, so we'll use a plus here. Suppose the revenue decreases by 25%, then we will put a negative sign here, minus sign here. So present value will be higher. So 100 plus x upon 100 multiplied by the initial value. Initial value is 32 million. As a result, once we substitute the value of 32 million here, the bottom, and then we calculate further, we will end up getting $40 million as the answer. This is when revenue has increased. So whenever revenue increases by a certain percentage, it should be added here. That percentage should be added to this 100. So it is simple. 100 upon 100 multiplied initial value, you have to add plus x. X is the increase, percentage increase. On the other hand, you also have to be 100%
Sir?
clear. Yeah.
Can you show the previous slide? I was right.
Okay. Right.
Thank you, sir. Sir, we will be doing that thing, sir. Indian number system and the international one also.
Yeah. We'll do everything. Don't worry. Whatever is relevant, we'll do that.
Oh.
See, I'm going to do all questions which have come in the exam, all concepts which have come in the exam, and we'll also do those questions which can come in the exam. Every year there are 20% questions which are new. So whatever is expected, whatever is part of the syllabus, we'll cover that. Then you need to be clear about the meanings of 4 words. This is something which someone had asked me today. Sharath had asked me about this. What are the confusing words? We need to be clear about the meanings of words such as by, becomes, to, and of when they come in case of the questions of mathematics. So let's first of all look at the meaning of the word by. If a question says that population increased by 30%, it means whatever was the population previously, we need to add 30% to it. So percentage increase of 30% means if previously it was 100, now it has become 130. Keep writing along with me. If population decreased by 30%, it means we have to subtract 30%. So if previously it was 100, now it becomes 70. Then comes the word becomes. If the question says population becomes 30% of the previous population, then you have to subtract 70. And if the population previously was 100, now it becomes 30. If the population becomes 130 of the previous value, it basically means you have to add 30%. So if previously it was 100, now it has become 130. Then comes the concept of 2. If the question says population changes to 30%, then we have to subtract 70%. If previously the population was 100, it will become 30 now. If population changes to 130%, it means you have to add 30%. Or if previously it was 100, now it becomes 130. If the question's language says population increases to 130%, it basically means we have to add 30% to it. So if previously it was 100, now it has become 130. So increases to 130% means increased by 30%. And they can use different words. They can use a by, or they can use a becomes, or they can use a change, or they can use an increase, or they can use a decrease. They can also use decrease. If population decreases to 30%, it means you have to subtract 70% of the value. So if previously it was 100, now it becomes a 30. When the population becomes 30% of a particular value, it basically means we have to subtract 70% of the value. So if previously the value was 100, if the population was 100, then it becomes 30 now. It is 30 now. If the population becomes 130% of the actual population, previous population, it basically means you have to add 30% to it. Or if it previously was 100, now it becomes 130. Either write it down completely or else take a screenshot of the slide.
Sir, will you be sharing the PPT with us?
I'll be sharing the videos with you all, not the PPT.
Sir, can you please share the PPT for maths only?
I'll share the important parts of it, don't worry.
Okay.
You find the PPT better as compared to actually writing on the screen? Yes, no?
I prefer writing, but in class it is difficult to write the whole thing, so that's fine.
No, but so stop me. Whenever you still have to write something, please stop me.
Okay, sir.
There are some particular slides which I not only want you to write down, but I also want you to take a screenshot of them. This is one of those slides. I want you to take a screenshot of the slide.
Sir,
Yeah, ask me.
can you please explain the part of becomes and into the first two?
Okay. If I look at question which says the population of a particular city becomes 30% of the last year's population, it basically means that we have to subtract 70% of last year's population. So if previously last year the population was 100, this population becomes 30% means that previous year's 100 has become 30 now. Similarly, if the question says the population of a particular city becomes 130% of its last year's value or last year's population, it basically means whatever is the last year's population, you have to add 30% of that last year's population to it again. So if last year it was 100, now it has become 130.
Okay.
So increased by 30% means becomes 130%, which also means changes to 130%. It also means increases to 130%. But
Well, I
I don't
understand
want
that.
you getting confused by the language of by, becomes, and to. This is the reason why I'm repeating this part. This is not maths, this is pure English. This is the English part of maths.
Oh, sir,
What?
is it that if it is 30%, that is, it is less than 100, right?
Yes, 30% is less than 100%. Always.
Yeah, but so that means that we have to know how to explain. We have
Yes.
to subtract it from 100
Yes.
and then write it You know, sir,
Yes.
when numbers come, even English is horrifying.
Yes, I agree. A maths question is not difficult because of the difficult maths. A maths question is always difficult because of difficult English inside it. Always remember that. The only way they can make easy math question difficult is by changing it to have more difficult English inside it. Okay. Now we're learning one more new set of concepts. Reversing a percentage change. What is reversing a percentage change? Some questions will require you to reverse a percentage increase or a percentage decrease. Whenever percentage decrease is needed to reverse a percentage increase, and percentage increase is needed to reverse a percentage decrease. So what does it really mean? Suppose there has been a percentage increase in something, and then the question says, by how much percentage is it to be decreased to get the original value? Or there's a particular value and there has been a percentage decrease in it, and they ask you how much should the percentage increase in order to get the original value. Then that is what is called as reversing a percentage change. This will become clearer when we do questions. So let's look at questions directly. And first of all, just write down the two formulas for these two things. When we do questions, this becomes clearer only then. Right now, just write the formula. Written it?
Yes, sir.
Okay. I'm moving ahead now. Look at this question. If the question says the speed of a train was 50 miles per hour, if the speed is increased by 10%, if its speed increased by 10% and 10% of 50 is how much? 5. So how much will the speed become? 50 plus 5. Then the question says, then by how much percentage is this speed, 55 miles per hour, to be decreased to bring it back to 50 miles per hour? So I'll just write it down here just for the sake of visualizing. Previously, the speed was 50, then it becomes 55. After that, I have to convert it into 50 again. So you can see that there is the first speed, then there is a second speed, and then there is a third speed. There are 3 speeds out here. The train was traveling at a speed of 50 previously. Then then the speed was increased by 10%. 10% of 50 is equal to 5. So the speed becomes 55. But the question is asking, we want to decrease the speed of 55 so that we end up getting 50. Again, original speed. Then how much percentage decrease has to be done in this 55 to get a value of 50? Now, when we look at this particular question, we may get an impression that this initial 50 is the initial value. But no, this is not the initial value. This was a speed previously. We are talking about these two values from which the answer has to be found out. 50 is the initial value in which a percentage decrease has to be done, to get a final value which should be 50 again. Keep this in mind. So I'll leave it on the screen and we'll move on ahead with solving the question. The solution is that we need to do a percentage decrease from a 55 to a 50. From this 55 second value to the third value, which is 50. So final value, remember, is 50. Initial value is 55. This is initial value. This is final value. So when I substitute the values in the equation, then what will I end up getting? I will end up getting 100 minus final value. Final value needed is 50 multiplied by 100 upon initial value, which is 55, which on simplification will end up giving me these set of values. 100 minus 90.9, which is equal to 8.1%. This is the percentage decrease which has to be done in this 55 in order to get the final value, which is 50. Understand it. In this question type, even if you know the formula, you can make the mistake of flipping between the final value and initial value. You may write down the final value as initial value and vice versa. So this question is not about maths. This question is about taking care that you don't make a silly mistake. You have to remember what is the meaning of final value and initial value in case of these questions. So remember, there are three values here. The first and the last value are the same. The middle value is always initial value, and the last value is the final value. Take a screenshot of this slide after you've written it down.
Sir, excuse me, I may be wrong, but wouldn't it be 9.1 rather than 8.1?
You are perfectly right. It would be 9.1. It's good. Somebody's made a calculation mistake here. I'll correct it.
Sir,
Yes.
sir, in the PPT, the
Okay. Ask me.
sir, can you show the PPT?
Yeah, I'm just showing it. I'll just make the small correction and then I'll just show it to you. Just make a small correction here. This should be 9.1. 9.1% instead of 8.1.
Sir,
Yeah, ask me.
sir, in this formula, whenever we have to put the final value, it is going to be the decreased one, and the initial value which we are going to put, it will be the new value which we get by doing that calculation if the
Calculation here.
speed is
Yes.
increased by
Yeah,
10%.
yeah. Yes, perfectly right.
Okay.
Can we proceed ahead? Okay. Now we are learning percentage increase which is needed to reverse a value. In the previous question, we did a percentage decrease. Now we are learning how to do a percentage increase. So in exactly opposite kind of a question, Suppose the question's language says the speed of a train was 50 miles per hour. This was the first speed. If the speed is decreased by 10%, when we decrease the speed of a train which is traveling at 50 miles per hour by 10%, then it will become 45 miles per hour. So 45 miles per hour is the second speed. And now the question is asking, this 45% per hour, miles per hour has to be decreased by how much percentage to bring it back to 50 miles per hour. So if you want, I'll write that thing again. The initial speed is 50. Later on, it becomes 45. And now I have to take care that it becomes 50 again. The question is talking about this particular part. How much percentage increase has to be done in this 45 in order to get a value of 50? This is what the question is asking. So the solution is we need a percentage increase from 45 to 50 because it had been decreased previously. So whenever the value has been decreased, you need to increase it back. Whenever the value has increased, you need to decrease it back. So now I'll write final value multiplied by 100 upon initial value minus 100. And final value, remember, is 50. Initial value is 45. The second value is always the initial value. The third value is always the final value. So I substitute the value of 50 here in place of final value. And initial value is 45. And I simplify this whole thing, 50 multiplied by 100 divided by 45 minus 100. And I will end up getting this final value. 111.11 minus 100, and I will end up getting 11.11%. We will not speak of this as 11.11%. We'll always speak of it as 11.11%. So this is the percentage increase required to increase the speed from 45 to 50. Middle value is always the initial value. Last value is always the final value. So whether it is increase or whether it is decrease, in both cases, remember that. The formula for both of them are two different formulas. So you need to mug up these two formulas. Understand them. I'll give you a lot of questions to practice upon that will help you remembering it also. I have one more plan in my mind. Somebody pointed about the PPTs, that PPTs are going to help in revising at a later stage. I agree. They can help you. But something which is even better is that as far as memory is concerned, there is something called as active recall, which helps you memorize things better. For example, suppose you are studying medieval history of India. And after some time, you want to check whether you've remembered it or not. So if you attempt questions based upon medieval history, then you will have to remember whatever you have learned. And whenever you strain your brain to remember what you've already learned, then you remember it even better. So what I will do is, once the syllabus gets over, I will give you a workbook which will have blanks inside it. So it will be like a workbook having all the notes, and the important parts will be blank. You have to fill up those blanks yourself from your own memory. In case you cannot fill up a certain blank, it means you have forgotten that concept. Then you check and you fill it up. You either ask me or else I can give you solutions also. So that way you can possibly revise things in a much better manner. So it's an idea in my mind. I'm going to share that thing for the initial topics, and then you tell me whether it is good for revising for you or not. Okay. So now we are trying to understand the differences between the two as such. These were the two questions which I had given you. I'll just remove this mark. In the first question, the initial speed of the train was 50 miles per hour. It went in for increasing by 10%, became 55. And then we had to decrease that 55 to get the final value, which was 50. In the second question, which we just did, the initial speed of the train was 50 miles per hour. This speed was decreased by 10%, so it became 45%. And then this 45 miles per hour had to be increased by a certain percentage value in order to get a final speed of 50 miles per hour. So here Where the speed had been increased, we had to do a percentage decrease. Here, where the speed had been decreased by 10%, we will have to do a percentage increase. These were the two solutions for both of these questions. This is still a wrong value. It should be 9.1. Who pointed that out? Who was it? Murli?
No, sir, not me. Not
Speak up.
me.
Who did
No,
it?
sir, not me.
Okay, okay. Who had pointed out this mistake? Man, I'm happy with you if you pointed out the mistake. Okay, Sharad did that. Sharad, good. Compare both the questions, compare the solutions, compare the formulas, understand what is final value and initial value in both the cases, how they're different, and how we end up getting different answers. This value should be 9.1, not 8.1. Are we clear? You can even take a screenshot of this present slide. But take care, this is 9.1 and not 8.1. Now take the screenshot. Okay, this is a very important concept. It helps a lot. It is not asked, but it is part of solving of questions. If A% of B is X, then what is B% of A? Let's understand this. If we are talking about A% of B, it basically means A upon 100 multiplied by B, which is equal to AB upon 100. Agree? Yes, no?
Yes.
Yes, sir.
Yes? So, A upon 100 multiplied by B should be equal to B upon 100 multiplied by A. This is also B multiplied by A upon 100 is the same as AB upon 100. So A% of B is always equal to B% of A. Suppose you have to calculate 88.22% of 50, which is a difficult calculation. This is where you use this concept that A% of B is equal to B% of A. So we cannot easily calculate 88.22% of 50. This is a difficult calculation, but we can definitely calculate 50% of 88.22. And 50% of 88.22 is very easy to calculate. It is 44.11. This is how this concept is to be used. So always remember A% of B is equal to B% of A. There will be a lot of questions where this particular concept is going to help you. Instead of doing this kind of a calculation, I want you to do this kind of a calculation. This is always easy. 50% is half. Half means whatever is 88.22, you just divide it by 2. So put a 2 here, divided by 2, you get a 4 here, a 4 here, then a decimal sign, then 1, 1. So 44.11 is the answer. Simple. But this will require a long calculation. Take a screenshot of this slide also, write it down also. Do both things. Ready? Then there may be a concept of comparing percentages to compare values. Suppose a question says if 25% of A is equal to 30% of B is equal to 12.5% of C, which is equal to 20% of D, and then the question requires you to find out the largest number and the smallest number. Read the question again and then explain it. Yes, Swetha, good answer. So let's understand it. You can see that in case of this equation, smaller part of C is equal to a bigger part of others. So if smaller part of C, 12.5% is small part of C, 30% is a big part of B. If small part of C is equal to big part of others, then C should be the biggest number. And a big part of B is equal to small part of others. It means B has to be a smaller number. So smaller percentage of C is equal to bigger percentage of others. As a result, largest number should be C. And because big value of B, big part of B is equal to small part of others, so B should be the smallest number. So if I arrange all of them in a sequence, ascending or descending order, then I will have this in case of descending order. C is the biggest, followed by D, followed by A, followed by B, which is smallest. So C, which was 12.5%, which was the smallest part, is the biggest actually, always. Done? Okay. I think the time is almost over. Let's do the questions, the first 5 questions which you already covered in the next class. What I want you to do now is I want you to revise whatever we've learned today. I want you to mug up those things which I wanted you to mug up, all those fractional equivalents. And starting from the next class, we are going to start with explanation of question number 1. I do not want you to attempt any more questions. I don't want you to attempt any questions from the exercise because we are going to continue the next class from the point where we are ending today. Any questions you have, ask me. For that, I'll answer your question. I'll just send you a message.
Sir,
Yeah.
sir, for the last concept, can you please explain that tomorrow?
I'll do that again. Remind me.
Yes.
So right in the beginning of the class, it is your job to remind me. Grace, I'm going to answer your question. Yes, Asif, I'm going to answer your question also. Is that okay? Enough for today?
So, could
Chalo.
you again,
Ask me.
could you again explain that point regarding initial value and final value? What was that point? That middle value is always initial
Always the
value.
initial is always called as the initial value of the equation
So in all the questions.
in all questions.
Okay,
Whether
sir.
percentage increase is required or percentage decrease is required, in all cases, the second value is initial value. First and third values are final values. And first and third
Okay.
values are the same, always.
Okay, sir. Thank
Okay?
you, sir. Yes, sir.
Chalo. Okay, bye. Good night. Have fun if you can have fun. If you can afford to have fun.
Thank you, sir. Good night.
Okay,
Good
bye.
night.
Good night.